Assalamualaikum. Hello each and everyone. My name is Mohammad Naim Romuros. My report is horizontal alignment 2 in CE62. Horizontal alignment 2 is this section discuss the design of super elevation and how it is attained. A brief discussion on pavement widening at curves is also given. Guidelines on super elevation. While designing the various elements of the road like super elevation, we design it for a particular vehicle called design vehicle, which has some standard weight and dimensions. But in the actual case, the road has to cater for mixed race, different vehicles with different dimensions and varying speed fly on the road. For example, in the case of a heavily loaded truck with high center of gravity and low speed, super elevation should be less. Otherwise, changes of toppling are more, taking into practical considerations of all such situations. IRC has given some guidelines about the maximum and minimum super elevation EX. They are all discussed in detailing the following sections. Design of super elevation. For fast-moving vehicles, providing higher super elevation without considering coefficient of friction is safe. Centrifugal force is fully counteracted by the weight of the value vehicle or super elevation for slow-moving vehicles. Providing lower super elevations considering coincidence of friction is safe. Centrifugal force is counteracted by super elevation and coefficient of friction. Design procedure. Step 1. Find E for 75% of design speed, neglecting F. E1 is equals to 0:75 V to GR. Step 2. F E1 0:07, then E equals E1 equals 0:75 V to GR. Else if E1 less than 0:07. Step 3. Find F1 for the design speed and max. F1 equals to V2. GR E equals V2 GR 0:07. If F1 greater than 0:15, then the maximum E equals to 0:07 is safe for the design speed. Step 4. Find the allowable speed VE for the maximum E equals to 0:07 and F equals 0:15. VE equals P 0:22 GR F VA. B then the design is adequate. Otherwise, use speed adapt control measures or look for speed control measures. Maximum and minimum super elevation depends on A. slow-moving vehicles and B. heavy loaded trucks with high CG. IRC specifies a maximum super elevation of 7% for plain and rolling terrain, while that of hilly terrain is 10% and urban road is 4%. The maximum super elevation is 2 minus 4 2 to 4% for drainage purpose, especially for large radius of the horizontal curves. Attainment of super elevation. Number 1. Elimination of the crown of the chambered section by rotating the outer edge about the crown. The outer half of the cross slope is rotated about the crown at a desired rate such that this surface falls on the same plane as the inner half. B. Shifting the position of the crown. This method is also as diagonal crown method. Here the position of the crown is progressively shift outwards, thus increasing the weight of the inner half of the cross section progressively. Number 2. Rotating of pavement cross section to attain full super elevation by. There are two methods of attaining super elevation by rotating the pavement. A. Rotating about the center line. The pavement is rotated such that the inner edge is depressed and the outer edge is raised both by half the total amount of super elevation, i.e. by E equals to with respect to the center. B. Rotating about the inner edge. Here the pavement is rotated, raising the outer edge as well as the center such the outer edge is raised by the full amount of super elevation with respect to the inner edge. Radius of horizontal curves. The radius of the horizontal curve is an important design aspect of the geometric design. The maximum comfortable speed of a horizontal curve depends on the radius of the curve. Although it is possible to design the curve with maximum super elevation and coefficient of frictions, it is not desirable because realignment will be required if the design speed is increased in the future. There are ruling minimum radius. Ruling can be derived by assuming maximum super elevation and coefficient of friction. Ruling is equal to V2G times E plus F. Ideally, the radius of the curve should be higher than ruling. However, very large curves are also not desirable. Setting out large curves in the field becomes difficult. In addition, it is also enhanced driving strain. Extra widening refers to the additional weight of carriageway that is required on a curved section of a road over and above that required on a straight alignment. This widening is done due to two reasons. The rest and most important is the additional weight required for a vehicle taking a horizontal curve, and the second is due to the introduction transportation engineering. Horizontal alignment 2. Tendency of the driver to fly away from the edge of the carriageway as they drive on a curve. The rest is referred as the mechanical widening, and the second is called the psychological widening. Mechanical widening. The reason for the mechanical widening are when a vehicle negotiates a horizontal curve. The rear wheels follow a path of shorter radius than the front wheels, as shown in this phenomenon is called tracking, and has the effect of increasing the effective width of a road space required by the vehicle. Therefore, provide the same clearance between vehicles traveling in opposite direction on curved roads as is provided on straight section. There must be extra weight of carriageway available. This is an important factor when high proportion of vehicles are using the road. Trailer trucks also need extra carriageway depending on the type of joint. In additional speeds higher than the design speed cause transverse skidding which require additional weight for safety purpose. The expression for extra weight can be derived from the simple geometry of a vehicle at a horizontal curve. Let R1 is the radius of the outer track line of the rear wheel. R2 is the radius of the outer track line of the front wheel. 1 is the distance between the front and rear wheel. N is the number of lanes. Then the mechanical widening Wm is derived below. 2 equals R21 plus 12 equals times R2 Wm 2 plus 12 equals R2. 2R2 Wm plus W2M plus 12. 2R Wm W2 M equals to 12. Therefore, the widening needed for a single lane road is Wm equals 12. 2R2 Wm. Psychological widening of pavement has to be done for some psychological reason. Also, this is a tendency for the drivers to drive close to the edge of the pavement on curves. Some extra space is to provide for more clearance for the crossing and overtaking operations on curves. IRC proposed an empirical relation for the psychological widening at horizontal curves WPS equals to V2 64 PR. Summary. In our country, the design of super elevation follows IRC guidelines. In the initial design is done by considering 75 of designing speed and the safety of design is assessed. Pavement is to given extra weight and curves to account for mechanical and psychological aspect. Thank you.